Assalamu alaikum guys, welcome to my channel Electronic Devices Analysis. So guys, our today's topic is to plot the output characteristics of common emitter configuration. This will be the part 4 of our common emitter configuration series. In our today's lecture, we will solve a problem based on common emitter configuration where we will find some parameters and at the end we will plot the output characteristics of this problem. So guys, let's start with the solution of this problem. The problem number 1 is, in common emitter configuration, if the base voltage is equals to 5 volts, RB is equals to 20 kilo ohms and VCE will be of 5 volts, and the applied voltage in the output loop is, the collector voltage at the output loop is 15 volts. Find the value of collector resistance RC and at the end plot the output characteristics of common emitter configuration if amplification factor beta will be given of 200. So guys, first we make the circuit of this problem. The circuit is, here is the resistance in the output loop and here is the battery VCC, and VCC is of 15 volts given at this point, and we will have to find the value of RC from there, and emitter branch is grounded, and here is also a battery present, and this battery is VBB and this will be of 5 volts, and there will be a resistance and the resistance is of 20 kilo ohms. You will have to find RC, the collector resistance. The RC will be connected with VC. If you find VC, then you will find RC from there, and to find VC you will first have to find IC, and to find IC you will first have to find IB, because IC will be of is equals to beta times IB. As the beta will be given, if you find IB from there you will find IC, and from IC you will find VC, and from VC you will find RC, and then you plot the output characteristics of this problem. So guys, first we find the base current. The base current is what? In the input loop there is a battery present and this battery is of 5 volts, and there is a junction present and this junction is 0.7 volts, because this will be a forward bias condition and it will be like a forward bias diode of silicon. So IB will be equals to the potential between two voltages 5 volts minus 0.7 volts divided by this resistance, and this resistance will be of 20 kilo ohms. So answer will be 4.3 volts divided by 20 kilo ohms is equals to 0.235 milliamps. So you will find IB, you will find IC, and IC will be of beta times IB, and beta of the transistor is given, this will be of 200, so 200 multiplied by IB of 0.235 milliamps, so this will be equals to 47 milliamps. So the value of IC is equals to 47 milliamps. Now you will have to find VC. There is a junction present which I will missed. This junction is VCE junction, and this value is present because here you will see that the collector meter junction is given 5 volts, so 5 volts will be over there. So from the output loop you will find the value of VC. The VC, the potential between two voltages divided by this resistance is IC, but the VC will be equals to VCE, the VCE will be equals to VCC. This voltage will be drop over this resistance, VCC minus IC into RC. So VCE will be equals to VCC, and the VCC will be of 15 volts minus IC, and IC we will find 47 milliamps multiplied by RC. So VCE will be given 5 volts, 15 minus 47 milliamps multiplied by RC. So 15 minus 5 over there is 10, and RC multiply with 47 milliamps, because 15 minus 5 is 10 volts, and RC into 47 milliamps will be go over there, and this will be plus. So RC will be 10 divided by 47 milliamps. So the answer is 0.212 kilo ohms. You will at the end find the value of RC, which will we have to find RC. Our first problem is done. Find RC. Now we have to plot output characteristics of this problem. In the output characteristics, you will know that on y-axis we will take the value of IC, and x-axis we will take the value of VCE. The formula of VCE will be equals to VCC minus IC into RC. In cut-off region, your VCE will be equals to VCC, because your IC will be equals to 0. If IC will be 0 over there, then VCE will be equals to VCC. This will be the cut-off region, and cut-off region will be over there. This will be of VCC, and VCC value is 15 volts. So write it again, VCC minus IC into RC. So in saturation region, your VCE will be equals to 0. So VCC will be equals to IC into RC, and IC will be equals to VCC over RC. This will be of for the saturation region. This will be for cut-off region. The cut-off region will be on x-axis, and saturation region will be on y-axis taken. So IC will be equals to VCC over RC. So 15 divided by 0.212 kilo ohms, the value of RC. Putting the value of 15 volts divided by 0.212 kilo ohms, this will be equals to 70.75 milliamps. So here is the point of saturation region, and this will be of 70.75 milliamps. These two are the fixed points. So for every value of IB, one line will be drawn over the plot. The output characteristics shapes are like this. For every value of IB, one line will be drawn over a output characteristics graph. So the IB value which we will find in the problem is 0.235 milliamps. So this will be of 0 milliamps, this will be of 0.1 milliamps, this will be of 0.2 milliamps, 0.3 milliamps, and so on. When it shifts towards the x-axis, then its value will be decreasing, and when it will move forward to the y-axis or upper side, then the value of IB will be increases. At 0.235 we will draw a line, and here cut the line over there, and this will be a straight line, and this point is called the Q point of the transistor. This will be the Q point of the transistor. The Q point is the stability factor. If the transistor Q point is more stable, then your transistor will work more efficiently. So this will be give us two informations. The two informations are ICQ and VCEQ. ICQ is simply IC. You will find IC in the problem. In the problem you will find the value of IC, and IC will be of 47 milliamps. So ICQ is 47 milliamps over there, 47 milliamps, and VCE will be given in that problem, and in that problem the VCE will be of 5 volts. So 5 volts and 47 milliamps, this will be ICQ, and this will be VCEQ, and this will be of 5 volts. This will be the information of the Q point. These are the output characteristics of common emitter configuration. That's the end of our today's lecture. If you like our video, then press on like button and subscribe our channel for more updates. Thank you. Let it go,